So yeah, Todd and Mark, it's your guys' turn. I'm sorry.
Well, Mark, do we have a camera on the device and a camera for the laser dot?
Okay, I probably can try to get that. So the device is right over here, and the laser dot will have the laser dot down on the other side of the room. So let me see if I can get a
okay
camera.
now. So this is let's preface this. This is the ion drive. Todd, could you describe this for us a little bit?
Yeah, it's very similar to Podkletnov's experiment. This is an aluminum tube. It's 4 inches in diameter and 12 inches long, and it's capped with plastic caps. So it's mostly sealed. There's a wire coming out the bottom that fills the bottom hole, and a wire on the connected at the top there to a threaded rod that goes all the way through. This device, inside it, there's a large capacitor, high voltage capacitor, and a spark gap, similar to what we were just looking at. When he charges it up and the spark jumps, the objective is, and we loosely call this an ion drive because really if it's not an ion drive, it's supposed to be, the idea is to simulate what we think a tic-tac is doing. And in that sense, as the capacitors charge up and they reach the breakdown voltage of the spark gap, the charge races around the outside of the tube. And because of the high voltage on the outside of the tube, it's attracting the air. And when the pulse of current flows, it will exert force on the air, causing it to change position. And Mark, how do you have that set up? You have it set up that if it thrusts up, the laser goes up?
Yeah. In this current configuration, it's set so that when it thrusts up, the laser goes up.
Well, I like the fact that there's kind of a model behind this too. I mean, with Podkletnov, I got the impression that it was very ad hoc, right? Like he was just doing experiments based on what he thought, and eventually he saw something work. So I like the fact with yours that there's kind of a model behind it.
Yeah, it's basically, I'm thinking in terms of if you were going to make a sealed tube that could move through the air really quick, how would I do it? And my objective is to gain traction in the air. So if we charge the hull up to a very high voltage, it attracts the air, and when it discharges and the current flows, there's an electric field that opposes it.
Okay.
That will push the air with it. So kind of like a frame dragging effect. And who knows, hopefully if it was in a vacuum and in a high enough electric field, you could get a frame dragging effect. But
well, that almost reminds me of what Justin was talking about with MHD, maybe, right?
It is. It's all related.
This camera needs to point the green dot.
It's kind of an MHD without the magnets and outside the hull instead of between the plates.
And later on, I'll see if I can find Naudan's page. He had one. His was very different. In fact, yours probably works a lot better. If but
I don't think it works great. We saw what it did last week, and it was
the laser dot over here.
Yeah, well,
but it did work. It did what we expected it to do. So it's just very small effect compared to what I was hoping for.
Yeah.
All right, Todd. So we have the high speed camera pointing at the screen right now, and that that should give us a view of the green dot over there. See if there's any. And are you able to see it on the Falcon?
You got to hook up the wires first before you line that up. It's gonna
that's true. That's true. I'm gonna hook up the wires first. Yeah, the wires will contribute a lot.
Yeah.
They bottomed out. Bring it out. So, funnily enough, we actually saw some results with this thing. It was kind of moving. Not a lot, but there was some movement, and there was a bit of a creep in the scale as well over time. So for the first setup, Todd, do you want to do negative on the inside or negative on the outside?
Negative on the inside.
Well, so if it's moving air, you have like don't you have a fog machine or something, Mark?
Yeah, we have a whole bunch of incense
worked
sticks.
last time.
The incense,
Yeah,
I
we
used to
were
use smoke bombs, but they cover everything with like everything
Yeah,
gets covered.
That's too much.
It's
That's too much smoke.
Yeah.
Yeah.
The incense worked okay.
Yeah, it
Yeah.
did work pretty well. I'll grab an incense stick. Or Jatine, can you grab one? Can you grab an incense
A
stick?
couple of them.
A couple of them. And a lighter. Okay, so we're hooked up now. Let's see if I can line it up. Sorry, it's going to take a little bit to get this thing going because we are using the exact same power supply we used for the impulse experiment. So now to keep the scale from jumping all over the place, there is a third arm over here. We put a little weight on that as well. Sort of balances out the scale. Let's see if we can find a sweet spot. Okay, now it's kind of hanging there. Are you guys able to see the green dot on the board?
On the other screen.
Yeah, well, not really. In a weird way, I can see kind of reflection of the laser. I think the board is too bright, but I could see a reflection there.
Oh, I could dim that down then. I just added another weight to it, so that should help balance things out. It's quite difficult to get this thing balanced. It just wants to go down now. That's what happens when your equipment is a little bit too sensitive and just wants to bounce all over the place. Okay, so maybe some.
You need a
Use a
damper
little,
on the.
a little bit of that
thing.
silly putty stuff to mount those close by, so we can get a good view of that.
You need to add a little bit of a damper on there, man. It's too.
There is a damper. I need to increase the damper size. Okay. So we're using for a damper, it's just weights on the bottom of it. And looks like we need to increase the weight. Put the larger lead weight on the bottom. I'm sorry I didn't have this all set up. It was impossible to have it all set up beforehand. Todd,
Yeah.
what's your plans with this device?
For right now, we're going to show this what it can do. Hopefully in the videos this time we'll get some good data, and then I have other versions of it I'm working on, more like the Podkletnov Impulse experiment, and then some other ideas to try to figure out how to maximize this, because I mean, obviously these devices, flying saucers, UAPs, fly, and conservation of energy and momentum tells me it's got to be moving some air. I'm yet to find anything that's going to move enough air to lift something the size of what we're seeing. So I'm still thinking about it. How do we manipulate gravity? How do we make this magnified? Terahertz waveguides. What's the effect of that on air? Or what is the effect of a terahertz waveguide on the outside of the hull? How is this
Yeah, we can
caused?
see the green beam now.
Yeah.
Okay, we're setting up the incense stick, so that should give us a better view of the air flows around it. And okay, now you can see the dot. Let's get that in focus. I'm going to lower the exposure time on this, so let's get it down a little bit. Too much. Okay, that's people walking through the shop right now. Okay,
Looks good.
oh, okay, can you just draw a black circle around where it is right now? Okay, I'm gonna scooch on past.
Yeah, the drifting is not important. What's important is that when it fires, and you'll hear it fire,
There shouldn't
it
be too
moves.
much drift in this
Yeah.
configuration. We are powered up and ready to go. It should trigger any second now. $25,000 in there. Now the air is blowing away from it now. There, it just triggered.
See it rise up when it triggers?
Fired. Fired. Yeah, it is rising up when it fires.
Don't always hear it. I don't know if it's rocking or what.
And so it's rising because of air movement, right, Todd? Is that the?
Yeah, when it fires, it's pushing air down.
Okay. Yeah.
You're able to see that air is blowing away from it now. Before the breeze was just going steady, and now the air is just blowing in a different direction. It's blowing out away from it.
By making the outside positive, we're repelling the positive ions from the smoke, but it's attracting electrons. And electrons have a much higher velocity.
No. Okay, so we powered it down right now, and now you'll be able to see the smoke is rising a bit straighter than it was before. There is a little bit of residual power in it. It's about 10,000 volts. The capacitors are not going to discharge in a second, but I'm going to charge them up again. And it's going to fire any second now. I'll just say each time it fires. Fire. 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 Fire.
You can see when it fires,
Fire.
it pushes the smoke.
You can see that, yes.
It pushes
we
it
can see that
down.
here as well.
It's pushing it down and out.
Yep, we can see that here. Also, last time when we had smoke sticks a little closer to it, there was these toroidal rings that were
Eddy
of
currents.
smoke in the air.
Like little solitons, kind of.
Yeah.
Like little donuts.
Yeah.
Donuts flying through the air.
Smoke rings.
Smoke rings, yeah, exactly. Now, just to make sure everyone understands, this experiment, we're working with probably less than 20 joules of energy here. These are high voltage but low power overall.
All right. Now imagine how much air this could move if it was 40 feet long and 10 feet in diameter.
Yeah, you'd need a lot of power for it, and maybe superconducting magnets or something along those lines.
But it may be able to like change speeds very quickly. If you can move a ton of air all at once along a long hull, it could move very fast.
Yeah, and again, in fact, I'll bring the page up on my end now.
I'll just give you ideas exactly what's happening. I'm going to walk through the beam for a second.
So I think that's pretty much it. Right, Mark?
You guys can see you could probably see a little spark going through where that hole, where the Kapton tape is. And
I can't see the Kapton tape.
There's Kapton tape covering the hull.
Camera up, Mark.
The camera's pointed at the floor.
Just there.
Oh, there it goes. Okay, I'm sorry.
Yeah, well, I would say this experiment is successful, right?
Yeah.
I would say, yeah.
Yeah, it's just not as much as I wanted it to move. I wanted it to have a little more kick to it, but I only put 4 capacitors in it. That hole is there because I designed it to fit 6. I have 2 more right here. Should have sent them to you with it.
Could someone briefly just go over what the experiment's about again?
Essentially, it's trying to simulate how I think a Tic Tac moves. The Tic Tac UAP, which is supposedly like a 40-foot long cylinder with nothing but some fins on the outside and no motors. So the objective is to show that from a charged energy source inside, without any exhaust coming from inside, just moving charge around on the hull can cause it to move.
Yeah, if you ionize the air, you can push against the air with a magnetic field. That's and when you guys want, I can actually put the JLN labs, and that's an ancient page. I mean, that's like circa 2001 or something.
I've probably seen half a dozen times.
Yeah. Well, I figured I'd put it up for the folks who were attending, and that way they could take a look.
Okay, is everyone seeing the green light as well on the whiteboard?
Mm-hmm.
That's on the second camera. Okay, yeah, because you need both of those in tandem in order to get an idea of what's going on over here. Basically, the laser light is shining across the shop about 20, 30 feet, something like that. We have a high precision balance scale with a laser light attached to it, and that's giving us an indication exactly what's happening with this test device. It's pretty low power, although I am smelling a bit of ozone in the area. It seems like the air inside of the test chamber has become more conductive because it's starting to fire faster.
Yeah, as it fires, it's eroding the steel rod. So if it makes some smoke in there, and eventually it's going to change the air. So
that's the settings on the power supply right there.
Yeah, I think you can shut it down. I think we've demonstrated what we want to show. And thank you, Mark. Appreciate the help.
So I'm going to remove the spotlight there. So let me put this thing back on gallery mode. Everybody, another applause, this time for Mr. Todd Desiato and Mark Sokol for working together for, I guess we would call it a successful experiment. So let me very quickly share the screen just so you guys can see this. And sorry, stop share. Let me share the correct screen. Yeah, there you go. Okay, so it's showing for everybody but me. There it is. This is, and I'll paste this link into chat here. Okay, this is the JLN Labs page. This is the one that I've kind of gone back to several times. His idea was based on past ideas. MHD, as everyone has described, is not new. Again, Justin Pearson was talking about something vaguely similar. Mark and Todd were working with an experiment that's vaguely similar to this. In JLNs, you can see this twisted coil here. Basically, he's using this, he's energizing this with the high voltage, and there's an electromagnet that's placed like underneath it or on top of it, around it. And you can, once you have ionized the air, you can move it. The other thing, and if you guys scroll down, let me see. Maybe this is the best one to show you. The Artem Morningstar. If I remember correctly, and again, you guys can see this thing is ancient. Oh, and he's not going to give you a better picture of the skin. So the idea was to create kind of a caterpillar drive. This glow discharge panel might be better. Basically, you can see he has a single coil here that's energized with a high voltage. The coil itself is supposed to move the air, right? And there are some other advantages also. Advanced reduced drag aircraft project. One of the ideas was if you put a high voltage on the air, it disrupts the boundary layer around a wing. And that's why people have claimed that this technology may already be in place on the B-2 bomber, because the boundary layer could be spotted by radar. And so the idea is if you disrupt the boundary layer, you can reduce drag at the very least. And that's something that we saw with lifters. High voltage ion flow goes right through the boundary layer and it just completely disrupts it. The other thing is with this coil, if this was a series of different coils, if you energize these at different times and then you move them, you can create a sequence that's like a caterpillar drive. It inches the air along it. And of course, if you do that rapidly, then in theory, you could create some kind of, fast airflow. So you guys have the link to the Naudan page. I just put that in there. He had a bunch of variations that he built on this. And again, he wasn't the first. He's just the one that comes into my mind. So let me stop sharing there. But I thought that would be, his approach, I guess, was kind of another approach. And then what Todd is doing is a little bit different. So okay, so I guess we should probably see what's up next, unless you wanted to describe that more, Todd. Did you guys have more you wanted to do there?
No, that's it.
Okay.
Unless anybody has any more questions, that's it.
So why don't we do this then?